I really love this problem because it sounds fairly boring, but once you solve it, it's actually pretty interesting. Pause the video to see what it says, but this is from a math competition for high school students from 1984. It's literally older than I am. So in the problem, some students are taking a math competition and their score is gotten by adding 30 plus 4 points for every correct answer minus a 1-point penalty for every wrong answer. There's no penalty for whatever's left blank, and so in this example, you would get a score of 88. But if you just knew that the total score was 88, you wouldn't know for sure how many there were correct. For instance, if you got one more answer correct, but you got 4 more answers wrong, the extra 4 points would be canceled out by the minus 4 points there. So Mary couldn't have gotten 88 points because John wouldn't be able to tell exactly how many she had gotten correct. In general, you can think of all the possibilities as being inputs to some function, and then the score being the outputs of that function. And you can see there's actually 3 different possibilities that would give you 88, but for instance, there's only one way to get 150, getting everything correct, and also only one way to get 0. Now, by the way, there are also lots of things that aren't possible. You can check and see there's no way to get 149 points. So John knows that Mary's score was above 80 and is able to exactly determine how many correct answers she got. So Mary could have gotten a score of 150, but the question was, what's the lowest possible score she could have gotten so that John would be able to figure that out? In the color scheme here, we're looking for the lowest blue point that's going to be above 80. This problem probably seems harder now than you first thought. It keeps fighting back. I love this problem so much. But let's continue working. So if there's only one solution, let's call it correct, wrong, and blank, that must mean that when we do that trick of, getting one more thing correct and then getting 4 more things wrong, it must be impossible to do that. And also if we go the other way and get 4 fewer things wrong and 1 fewer thing correct, that also must be impossible. Because after all, we're saying there's only one way to get that score, and so these deviations aren't going to be allowed. But why wouldn't that be allowed? Can't we always just do this? Well, let's think about what happens when we go up. If we take 5 problems that were formerly blank, and we make 1 of them correct and 4 of them wrong, it must have meant that we had at least 5 blank things to deal with. And so if we want to make it impossible to go in this direction, that will happen whenever we have 4 or fewer blank problems on our test. Similarly, if we had enough wrong answers, we could just erase 4 of the wrong things and leave them blank, and erase 1 of the correct things and leave it blank, and that wouldn't change our score. And so to make sure that it's impossible to do that, we need that W is 3 or less. And so if we want to make the score as small as possible, we want to max out the number of wrong answers and also the number of blanked answers, and we see that the score would be 119. Note that we can get exactly that score with 23 correct, 3 wrong, and 4 blank, and that there are multiple ways of getting 118. And our argument actually shows that if there's a way to get something smaller, there's going to be multiple ways of doing that. There's a few more details we should probably be careful about, and I'm just going to go into one of them since you watched all the way to the end of the video, which is how do we know there's not some other, maybe mysterious way that we could also get 119? And I'm going to show for any score, if you could get it in 2 ways, maybe with a pink correct and wrong and with a black correct and wrong, if this were true, then we could solve this equation, we could cancel some things, and we would see that this left-hand side is a multiple of 4, and that must mean the right-hand side is a multiple of 4. And we could solve for that pink W in terms of the black W, and we would see it's a multiple of 4 greater. And so if that multiple of 4 is 4 times k, well now we can divide this equation by 4 and see that the pink C has to be the black C plus k. And very importantly, it's the same k in both of these things. And so whatever the pink C and W are, they're going to be the original ones plus 1k and 4k. In other words, that game where we added 1 correct answer and 4 incorrect answers, that's exactly what this is describing. This is at the heart of something in number theory called linear Diophantine equations. And I think it's pretty hard for high school students. What do you think?